Hello. Today I want to talk about this problem 1 on set 11. All right, so here's some initial value problems with solutions you should learn to write down by inspection. You know how I love these solutions by inspection. In all cases, the solutions are functions of t, and all others other than y and t are constant. So in particular, k is a constant. I want to focus on these two here. You might have noticed that in worksheet 15 here, we have an initial value problem of that form, y double prime minus y is 0. So that would be y double prime equals y, so k would be 1. And here in workshop, we have y double prime worksheet 16, y double prime minus 4y is 0, or it could be y double prime equals plus 4y, so k is actually 2. Here, k is 2 because 2 squared is 4. So let's go back to the things here. So we put you notice that these have a k squared y, so that just stands for any old positive constant. If y double prime is a positive constant times y, I'm in this situation. If y double prime is a negative constant times y, I'm in that situation. All right, and then what I'm going to do is I'm going to find this most beautiful form of the fundamental solution set. I have one solution where y of 0 is 1 and y prime is 0, 0. Another solution, y of 0 is 0, y 0 prime is 1. And then that again, I think it's number 16, where the name was the most beautiful fundamental solution set. All right, I'm going to stop the share and just go to this problem here. All right, so there's another video where I go through a little bit about cosh and sinh. But hyperbolic cosine and hyperbolic sine are super important functions that are always like the optional in Calc 1, but we're talking about it now. So the hyperbolic cosine, cosh of t, is e to the t plus e to the minus t over 2. And you notice that cosh is even, because cosh of negative t is the same as cosh of t. And sinh of t is e to the t minus e to the negative t over 2. And this is an odd function of t, because if I take sinh of negative t, these things switch with the minus sign, I get a negative. The other thing is I differentiate this, I just pull down a minus sign and get sinh. If I differentiate sinh, I pull down a minus sign and get cosh. It's simpler, it's better than cosine and sine. Okay? Because I never have to worry about any minus signs in the derivatives. The derivative of cosh is sinh, derivative of sinh is cosh. That's all there is to it. Cosh of 0 is 1, like cos of 0 is 1. Sine of 0 is 0, like sinh of 0 is 0, like sine of 0 is 0. So about like sine and cosine, only better. All right, so let's go and actually do these problems. So if I plug in y is e to the rt in this, I get r squared is k squared. That means that r is plus or minus k. I know it can kind of freak you out because it's not a number like k squared, not like a 9 there, where k would be 3. If k squared are 9, k would be 3. But heck, it's okay. So the general solution is y is c1 e to the kt plus c2 e to the minus kt. Right, and then y prime is k c1 e to the kt minus k c2 e to the minus kt. Okay, so that means that y of 0, which is c1 plus c2, is going to be 1 in this case, and y prime of 0, which is going to be k c1 minus k c2 is 0. All right, I can solve these, right? Get C1 plus C2 is 1. All right, this one here tells me that C1 equals C2, right? From the second one. So that means I get C1 equals C2 is a half. And I get, what do I get here? C1 equals, if C1 and C2 is a half, I automatically get, I'm done. I automatically satisfy that. So I get y is a half e to the kt plus a half e to the minus kt. Whoa, look at that. That's cosh. That's cosh of kt. Cool. So y equals cosh of kt. That's COSH, hyperbolic cosine. Let's get rid of all of this stuff. All right, now let's do the second one here. We have the same general solution. The only thing that's different is the initial condition. So this becomes C1 plus C2 is 0. And then I have K C1 minus K C2 is 1. Those are the two systems of two equations and two unknowns of C1 and C2. All right, and then I get that C2 is negative C1. That means K times C1 plus K times C1 is 1. In other words, 2K times C1 is 1. C1 is 1 over 2K. So that means that y is 1 over 2k times e to the kt minus, right, 1 over 2k e to the minus kt. So let's write this as y, let's factor out the 1 over k. Then I get a half e to the kt minus a half e to the minus kt. Cool. Oh, look at that. That is just sinh of kt inside the square brackets. So this is going to be y is 1 over k sinh of kt. Cool. So actually, let's just write those. That hyperbolic sine. All right. So these are a new fundamental solution set. Okay. There's lots of different fundamental solution sets for this differential equation. Oops, plus k squared. All right, so again, I have the way that I get an arbitrary positive constant in front of the y prime, in front of the y is to call it k squared. All right, so I can have e to the kt and e to the minus kt. That's one fundamental solution set, but the most beautiful fundamental solution set is cosh kt and 1 over k sinh kt. All right. So there's two different ways of writing the general solution. Y is C1 e to the kt plus C2 e to the minus kt. Gag me with the spoon if I got to solve some initial value problem. Or y is C1 cosh of kt plus C2 sinh of kt. Nothing to do, this is much nicer, nothing to do if I have an initial value problem. Because of this, y of 0 is C1, y prime of 0 is C2, if I make sure I put in the 1 over k there. Right? Cool. So in other words, I can solve things like, suppose I have an initial value problem, y double prime, let's get rid of all of this. Let's be really specific. Suppose I have y double prime equals 16y, and y of 0 is 13, y prime of 0 is negative 8. All right, why not? So what is that? I'm going to do y is, I get the 13 times cosh of 4t because 4 squared is 16. And then I get plus -8 over what is k is 4 times sinh of 4t. All right. So you should strive, and I could call it -2 if I want, but you should strive to be able to do these by inspection. Hey, let's show you, and I'm going to actually go back and share the screen again and show you back to problem. But I can get there. Oh, I've lost it. I need to, there it is. There it is. Good. Yeah, let's just do these. All right. Here we are. So by the way, this is not randomized. I should maybe tell you, but I will. Come on, how come I can't type it in? COSH, cosh of KT is that solution. 1 over K sinh of KT is the solution, okay, that satisfies y of 0 is 0, y prime of 0 is 1, right? The derivative, let's think about the derivatives. The derivative of this function of t is 1 over k times cosh of kt times k from the chain rule. The k's cancel, and I just get cosh of kt, and that is cosh of k times 0 is 1, right? All right, so what do we have here? I would like that, that really should be a y naught, and that should be a v naught, but we can't put y naught and v naught in web work. So this is really just a cosh kt plus b over k sinh of kt. Cool. All right, let's see if I got those right. Yeah. And web work is of course friendly. If you don't want to deal with cosh and sinh, you don't have to. I could have called this e to the kt plus e to the minus kt over 2, and I've got to put that first parenthesis in there. Let's see if that's right. They'll probably say that's equivalent. Okay, that's equivalent. And after so if I did all that, let's go here. I could do that. Copy. Maybe over here I did this. Oops. Paste. Okay, it gets a little bit. Well, I think I screwed up. It seems a bit too much. There's it. Okay. All right. I could put a minus sign here. And then remember, if I just divide by 2k, that's going to be wrong. I got to put if the k is in the denominator, I need to put 2k. Let's see if that works. Yeah, that's also equivalent. And you see this answer preview is awesome. All right. And then what do? I could, over here, I could have used this in front of A. And I could have used this in front of B. That whole thing in front of B. Let's put a space there. This will also work. So yeah, this problem is reasonable for even for people who never heard about cosh and sinh. You can still do it, but you certainly don't expect you to memorize that. To solve it by inspection, we want to use the cosh and sinh thing. All right. Okay. All right. Well, good luck on this set. And I'll be seeing you. Goodbye. Let's stop the recording.